Hello everyone and welcome to lecture number 13. Up till now we have started the microwave devices, and in that we have started our discussion with gun diode, and gun diode is working on the principle of TEDs. They are also known as TED, that is known as transferred electron devices. Those are nothing but transferred electron devices. So gun diode works on the basic fundamental of transferred electron devices. In that we have seen the energy band gap, that is EK diagram. This is E, this is K, this is valence band. You will have conduction band. This is the conduction band. This is V valley. This is U valley. This is U valley. Okay, V valley and U valley. So after some potential, electrons over here will transfer from valence band to conduction band. Further increase in the potential will transfer electron from V valley to U valley in the conduction band. And this transfer, remember, this transfer are responsible for the increase in the effective mass of an electron and decrease in mobility. Increase in MO effective mass and decrease in mobility. Okay, increase in effective mass and decrease in mobility. This is what we have already discussed in gun diode. Now in today's lecture we are going to study pin diode. Okay, the name itself suggests that PIN diode. Okay, so if you see the full form of this, then it will be P, then intrinsic dot N. Okay, so PN junction is been separated with an intrinsic region. Remember, intrinsic semiconductor or intrinsic region is the semiconductor without any doping. Undoped semiconductor is intrinsic. If you dope semiconductor with the material having more number of holes, then it will form P type. If you have doping of more number of electrons, then it will have N type, means depending upon the trivalent and pentavalent impurities. Okay, you might have already studied the trivalent and pentavalent impurities. Trivalent and pentavalent impurities will give rise to N type or P type, different kind of semiconductor. But intrinsic is nothing but the undoped semiconductor. Intrinsic is nothing but undoped semiconductor. Okay, so first of all, let us see the structure of the device. The structure of the device will be something like this. Okay, you will have, this is the P type, this is N type. You will have contact, you will have another contact. This is P type, this is N type. Okay, this is I. Intrinsic. Okay, and these two are two are metallic contacts. Okay, in a normal p-n junction, what we are seeing is we just have p-n junction diode. P-type material is directly contact with n-type material. But in pin diode, that is p-type intrinsic material and n-type, you will have intrinsic material in between n-type semiconductor and p-type semiconductor. P-type semiconductor and n-type semiconductor are being separated by an intrinsic semiconductor. So this is the structure of a pin diode. Now let us see some of the statements. It is already been observed and seen that pin diode, the semiconductor wafer, has heavily doped p-type region, heavily doped narrow p-type region, and separated by heavily doped narrow n-type region. This is also heavily doped n-type region, separated by the intrinsic semiconductor. Okay, that is thicker. You can see the thickness of this intrinsic material. The thickness of this intrinsic material, the thickness is greater as compared to p-type and n-type. Okay, you can see the thickness of intrinsic material is greater than p-type and n-type material. Okay, this p-type or n-type material or pin diode act as a pin diode acts as a low frequency rectifier. Low frequency rectifier that could rectify more power than an ordinary p-n junction diode. Okay, this is the important and the difference between a normal ordinary p-n junction diode. You can see that pin diode is used for low frequency rectification that could handle more power. As you know, in microwaves can handle more power. As you know, in microwaves we are dealing with more power of the signal, more power than the normal signals. So pin diode is useful in microwaves frequencies. Why? Because it can handle and it can rectify more power as compared to ordinary p-n junction diode. Okay, and at high frequencies and at higher frequencies, the pin diode acts like variable resistance. Remember, this is also very important. Pin diode act like variable resistance, means as we change the frequency, as the frequency of the signal changes, the resistance of the diode changes with respect to the applied frequency. And rectification ceases at higher frequency and rectification stops is at higher frequency due to carrier storage. Carrier storage junction and the transit time across the large intrinsic region. Across the large intrinsic region. Okay, so what happens at higher frequencies? At higher frequencies, you see, at higher frequencies, charge carriers are nothing but electrons in n type and holes in p type, while both the electron and holes will be the charge carrier in intrinsic. Okay, so this charge carriers storage junction, charge stored junction, and due to the transit time is nothing but the time from p type to n type and n type to p type, it will have a large intrinsic region to travel. It will have a large intrinsic region, and due to carrier storage at the junction, it is going to cease the rectification at higher frequency. Okay, so this is all about the PIN diode. Now let us see that how the resistance is varying, and with respect to lower frequency and with respect to higher frequency. Okay, under zero and reverse bias, the variation in resistance is nothing but the property of the applied field or the applied bias. Means the type of bias will define that how the resistance is going to change with respect to frequency. Under zero bias, zero and reverse bias, under zero and reverse bias, the diode has a very high impedance. Okay, under zero and reverse bias, the diode has a very high impedance at microwave frequencies. And a very low resistance and a very low resistance or very low impedance. We have used impedance, a very low impedance for even small forward current. Okay, that is with bias variation, on a PIN diode, its microwave, remember this point, its microwave resistance, changes from one value to another. They have also given the value, so let us see the value. Changes from nearly 5 to 10 kilo ohms. Remember, this is kilo ohms. Under reverse bias, RB is nothing but reverse bias. Under reverse bias to around 5 ohm or 1 to 10 ohm, 5 ohm or 1 to 10 ohm under forward bias. FB is nothing but the forward bias. So we can say that it behaves as a microwave switch. It behaves as okay, so it behaves as a microwave switch. Now let us see the construction. Let us see the construction of pin diode This is the front. The construction of pin diode will have silicon chip silicon chip. SI is nothing but silicon chip. You will have a contact wire. Wire contact will be there. And this is the wire contact. Okay, so this is the wire contact. This is the housing and this is the metallic end cap. This is the metallic end cap. Okay, this is the metallic end cap. So this is the construction of a pin diode. Let us see the equivalent circuit of it. Equivalent circuit is consisting of resistance, that is variable, and capacitor and two terminals. Okay, this is RB, this is C of J. This is nothing but the equivalent circuit of a pin diode. Equivalent circuit of a pin diode. Okay, now we have also discussed that with respect to the applied potential, we will have V versus R resistance, the relation of resistance versus voltage with respect to bias, and that will be, we can have the behavior something like okay, this is IR, this is V, this is RD, the resistance of a diode, and resistance variation with this is nothing but the resistance variation with bias. So as you vary the voltage, IR will be near about constant. As you vary the voltage with respect to the diode, you will have variation in resistance. As you increase the voltage, you can see the resistance is dropping. The resistance is dropping. That is more number of charge carriers, more number of carrier T, majority charge carriers are traveling from intrinsic region from P to N and N to P. So this is nothing but the relation between the resistance and bias for a PIN diode. Okay, so this is all about PIN diode.